was probably bad. Is that the raw score?
That makes me feel good.
Both.
That's how
So, ladies and gentlemen, now we're going to learn today about the ambiguous case of the law of signs. Peculiar. Now, this is related to this concept. I don't know if back in the day you remember proving triangles congruent, and if I had like two triangles in geometry. Well, we're not doing proofs, but this happened where you could prove two triangles congruent if you had side, 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 congruent to side. Let's see, I just did that backwards. Side and side. Right, so side SSS was one of the ways to prove triangles congruent. You don't have to write this portion down if you don't want. So side, side, side was a legitimate way to prove triangles congruent. Then there was side, angle, side. So if I proved these...
I remember some of this.
You remember that? That was another way to prove triangles congruent. All right? So side, angle, side worked.
That's the other one, wasn't it?
There was also angle,
ASS.
angle, side.
Angle side side?
Let's see. Angle, side. So angle AAS.
And isn't there an...
Not angel, no.
Isn't there an
Let's see.
ASS?
Oh, no, sir.
No.
Wait, let me get it. It's a quote from the TV show Color Crew.
Is that a quote?
I think that's a quote. It happens anytime one of the crayons colors the wrong thing the wrong color.
Wait, what show is it?
Color Crew. You don't watch that, guys? My son watches it all the time.
I watched SpongeBob.
The magic hat picks which color is the color of the day. No? Anybody? No? Okay. So anyways, let's see. I feel like I'm missing one.
Yes.
Oh, angle, side, angle also existed. So angle, side, angle. So that is the included angle between those sides, where this is a non-included angle between the sides. So notice that...
Question.
What's
Why
up?
isn't there an angle, angle, angle?
Yeah, that was my question.
Okay, actually, good question. Angle, angle, angle. Now, what about this? What if I've got this triangle and
That's a
this
horrible
triangle?
looking triangle.
And what if I said all three angles here are congruent to all three angles there? Those triangles are not congruent,
Unless
but
that...
they are similar.
Unless that... The second one isn't drawn to scale.
No. So similar triangles, or triangles can be proved similar using angle, angle, angle. And actually, better yet, they're like, you know what? We don't even need the third angle. We only need two angles because once you know two angles in a triangle, you could just subtract them from 180 degrees, and you know the third one. So they even shortened it from that. But that only proves similarity, whereas, actually, similarity, I'm forgetting.
Isn't it just a squiggly line with a normal line?
This is congruent. Wow, I can't believe I
Isn't
forgot.
it just one line?
I think it's just this. Anyways, I don't remember. But angle, angle proves similarity. These prove congruence. But my point is, there was no such thing as a $sign because of what we're going to discuss today. All right? It doesn't exist.
At money.
A money. So, angle, angle, side. So I just said that wrong. Angle, side, side does not legitimately prove triangles congruent. There was, however, a special case back in the day. So let's see. Let me swipe that out.
Oh, I just got that.
Took me a little while, really.
There was, however, a special case where it did work in the case of right triangles. If I have two right angles and then side and a side, those could be proved congruent by an angle side-side
So
situation.
there
However,
isn't.
nope,
Ass.
it's called hypotenuse leg.
Oh wow, they just didn't want to use
Hypotenuse
ass.
leg. Well, watch your language, friend. It works in a very specific case, only in right triangles. So with that in mind, let's analyze why does angle side-side not work? And this is where the ambiguous case of the law of signs comes from. Sure, you could try drawing this picture if you want.
No.
So let's say I know an angle, and I know this side right here, okay? So I know this angle and this side's length. And this keeps going. Wherever this third side intersects it is the length of that one. So I don't know that. But consider what if my third side I knew the length, and what if it landed right here?
That'd be pretty
Okay.
amazing, wouldn't it?
All right, so I know the third side, okay? Or second side, whatever. Now the issue is, I don't know whether the triangle is shaped like this or like this. Because what can happen is, like a door swinging on a hinge, this segment, because I don't know this angle up here, if it's a big angle or a little angle, it could swing and hit that other edge at two possible spots. So there's two cases, all right? So two cases could occur.
You forgot the...
Hence, this is ambiguous. I don't know if I've got this obtuse triangle or if I've got this scalene triangle. All right, so I have two cases. So I could have had little skinny triangle, or I could have had kind of bigger scalene triangle. Maybe that's a little exaggerated. Right, so two possible situations. All right, and that is the issue. Unless I know the angle, I can't figure that out for sure, and it doesn't quite work. So this is what the law of sines can also end up dealing with. All right, so technically back here, you couldn't prove the triangle's congruent, but you could have said maybe there's a 50% chance of them being congruent because it would have landed in either of those cases. All right, so this is what the ambiguous case of the law of sines deals with, is trying to figure out when is this side going to be making this case, and when is it going to be making this case? And then I guess there's technically even a third case.
Oh my god.
Well, where you could have specifically one triangle. What if it was exactly the right height
But
that it landed there and made a 90-degree angle? Then there's only one possibility that could have occurred. All right, so it could have landed in a right triangle situation, and there's only one case. Okay? And then there's also the possibility, what happens if my angle and my side, what happens if this other side's just too short? And it's like,
not a triangle.
and it's doing one of these. Here we go. Let's see if I can do this. Ready? Let's see. Here. And this is what it would be doing.
Wait.
So we'd have like
Focus on.
a side going out this way. We'd have an angle going up, right? And then this other side is like, and it can't reach the other side. It's like, oh no, I can't form a triangle, right? So if that's too short,
Then you
it's
have
not
to
gonna
bend
reach.
the other one. You have to like...
Yeah, and then it would change my original angle, and it would all be bad stuff. Blah. Exactly. So, so there's kind of a few situations here. So these occur. So these two occur. I guess maybe I'll summarize it like this: if if my opposite side is longer than the height. Okay? This situation occurs if the, let's see, how do I want to write that? If the opposite side equals the height, and this situation occurs if the opposite side is shorter than the height.
What's the word to represent that triangle? Because, or the non-triangle.
You would say there is no triangle, and when you were looking at answer 11, that's what that 0 was referring to, saying there were no triangles formed by the situation presented. So they gave us a fake triangle in tonight's problem number 11. Is that actually in tonight's homework? What do you know? It is. So the answer to problem 11 is 0. There are no triangles possible. Okay? So these are the situations. And what do I mean by height? I'm talking about this height. All right? If it's longer than the height, then there's enough for the door to swing and hit a couple spots. If it's equal to the height, it's landing exactly right there. All right, so here's my height. And if it's too short, if it's shorter than the height, then it can't reach the other side. And it's doing the whoop, 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 whoop. Isn't that like a dance move that people are like,
It's the robot.
one of those?
It's the robot.
That's what it reminds me of. Oh, all the way around. There you go. Pretty good stuff. Oh, wow. Man, I didn't even know.
What?
Wow. My students are teaching me the robot right now.
Oh, you look like this.
So anyways, so those are the multiple situations occurring. Now, technically, these are cases...
Ratatouille.
Ladies and gentlemen. Oh, someone say ratatouille?
Chicken fingers and ratatouille.
What if they could find us by knowing what weapon
They can. Well, I can anyway. Let's see.
You are just a math wizard.
So these cases that I'm showing are specific to when our angle is acute. And what I end up having here for us, let's see, the wind is blowing it around, is I've got a table breaking this up into several situations. I'm going to pass this out.
No, you put the money sign.
Of course I did. What do you think I am? Some crude person?
Yes, I'm a crude person.
There's no donkeys in math.
Correct.
I'm going to be popular. That's my finger.
So I've got multiple situations. Yeah, your finger was famous. You could be a hand model.
Like Sean Spencer.
There you go. So solving right triangles, I've got kind of an outline here to summarize some stuff for us. And friends, so check this out. Let me summarize this for you so you can narrow down your situation. So for solving triangles, if I have a right triangle and I'm given two sides, the recommendation is use the Pythagorean theorem to find the next side, and then find one of the angles using a trig inverse. So like you would set up, sine of theta is equal to some number over some number, and you'd end up sine inversing to find your angle.
like the last quiz?
Because I'm doing it now. If I have a right triangle and I have one side and one angle, use a trig ratio to find the missing side, and then use triangle sum, right? Since I'd know two angles, I'd know a 90 degree and one of the acute ones, I could find the third one by subtracting them from 180. All right? If I have a non-right triangle and it's angle, side, all right, then you just use law of sines, and technically this one you could do 180 minus those angles for that. And then if I have a non-right triangle and it's AS dollar sign, the situation we're talking about today, we're going to use law of sines to find it. Well, actually, today I think we might just get to the analysis, the actual test. Tomorrow with law of sines, we'll actually solve for both possible cases when there were two. And we'll end up using law of sines to find the side, and then your angle you could also use law of sines for. And then we'll end up learning this law of cosines for these other two cases, side, angle, side, and side, which I think I mentioned in yesterday's lesson video, and I was like, oh, I can't do law of sines with it. So what it's saying is whenever you have an angle, side situation, you're going to have to go to this next table, this bottom one here. So this is the AS dollar sign test. And there's different situations. So the situations I first described were our angle being acute. And I said, okay, so if your adjacent side is the largest, all right, and your opposite side is small compared to the height. What?
High, small.
Yeah, I'll explain that in a minute. So if the opposite side is smaller than your height, I actually have a formula for your height here as well, there's no triangle formed. Okay, so that's the little one of these. Here we go. Let's see. One of these ones. And it can't reach the other side. All right? I'm not good at your dance moves you're describing. Okay, so that's what that's saying, so no triangle. What if it's an acute angle, and it's a tie between the opposite and the height?
Oh,
that's when it just lands perfectly and ding, forms a 90-degree angle, and there's only one triangle formed. So that's what it says. And, more specifically, it's a right triangle.
So
and then,
always happens when they're the same.
right. And when the opposite side is larger than the height, then there are two triangles formed, and that's kind of where the door swings and it hits in two spots on the wall sort of thing. I don't know what you want to describe that as. And then there's the situation where, what if the adjacent side is smaller than the opposite? I didn't specify that one. but there's only one triangle there. And then there's these two cases for obtuse triangles as well. And it's possible to have no triangle or one triangle. But today we're specifically looking at kind of analyzing the height and figuring out how many triangles exist. All right?
A lot of triangles exist in the world.
So that chart is something that you can use. Actually, I'll show you what the book's got. The book has this little table here. So here they have your acute cases, and then blah, blah, blah. And then up top over here they have your obtuse cases. So you can see that if my adjacent side is longer than my opposite side, then the opposite side can't reach. It's like, I can't reach. Right? It's like some dramatic sort of
It's praying to
happenstance
God for...
to be a triangle.
Yeah.
I'm thinking of like an action movie where someone's like hanging off of a building and then like, I can't reach you. And they're like, oh, tell Dad I said I love you. I'm proud. Oh. And then like they fall because they can't reach. So it's
You
like,
said I'm black.
I'm proud.
Oh.
Anyways, I don't know. I don't know what people say when they fall off ledges.
Don't drop me.
Don't drop me, maybe. But this is the situation where the person up on the roof can't reach the other person. It's a sad story. But in this case, if the opposite is bigger than the adjacent, then like it could swing here, and then look, it's swinging way over here, and it's not even hitting a triangle for the second case. So that's why we're really only having one situation there. So let's
Solution.
So let's talk about this. Let's do an
So
example.
now should we start writing things down?
Yes, and I'm going to have to cut this video short in 8 minutes. I've got to go to a meeting. So we're going to do as much as we can.
Do you want me to save you leftovers?
No, sir.
You sure?
There's no such thing as leftovers.
Yes.
Because we lost the Hunger Games because Jess is competing right now with other students in the state.
You.
If she wins the Hunger Games,
Sorry, who?
nobody.
Scumbag Jess.
Actually, isn't Foxface one of the characters in the Hunger Games? In the books? The redheaded
Well,
girl?
now you're giving out the last thing to do.
Well, no, or maybe she just looks like a fox. I don't know. Maybe I teach a series of animals, stuffed
I
animals.
haven't seen the second movie yet.
Maybe people on the internet don't know if I'm just in a room by myself teaching math, making voices, and playing with stuffed
And you got a
animals.
little button where all the students laugh.
Yeah.
It's like, I won.
For all they know, that's what's happening.
But they saw my finger.
Maybe that was a severed hand. I don't know. That things just got really dark. I'm sorry. Determine the number of possible triangles.
And that's why last video you were talking to Mr. Morris, our principal.
I'm really good with voices.
Oh.
Maybe I can do a ventriloquist act. I don't know.
Maybe you're just as good as Jeff
Maybe
Dunham.
you are all of us.
Mm,
Maybe you can put multiple personalities.
Maybe I'm you from the future.
that would be crazy.
You and me.
So, check this situation out. So, here I've labeled some information. Let's draw our picture. All right? And I always draw these in exactly the same format. It's best that we do that. Right, friend over there with your cell phone?
Hold on, one.
So, here's 30 degrees. This is angle A. Side A is opposite of that. Let's see, side B is 10. All right? And side A is 3. So I'm trying to figure out, all right, so little a is opposite angle A. Here's side B. So I like to actually, consider this, break this down as the opposite side.
Did you say animals or stuffed animals?
Oh, that's a loud. That's really.
And B is the adjacent side.
Wait, how do you know
Okay.
it's short though?
Well, I don't know yet. So maybe it reaches down and hits twice. Maybe it's just enough to land once. I'm not entirely sure. But that's just kind of like my general idea for the sketch. So in order to really figure this out, I got to figure out what is this height. And in order to determine that height, check this out. This, with the yellow part, is a right triangle. And if I wanted to find height, it's the opposite of that angle, right? And 10 is the hypotenuse. So I would use sine.
It's just opposite to that.
So I could have said sine of 30 degrees is equal to the height over 10. So height is equal to 10 times sine of 30, which is why I wrote the formula on the little sheet. I say you don't have to solve this every time. You just use the formula. H is equal to the adjacent times the sine of the angle. And that will work in all of these situations, all right? So it's the adjacent times the sine of the angle. What is sine of 30, guys?
1/2.
1/2. So H times, so H equals 10 times a half, which is 5. So how does my opposite compare to the height? Right? The opposite is less than the height. So think about this graphically first of all. So if this is shorter than the height, even if it was facing in exactly the optimal direction, it's not reaching far enough. It's swinging, and it can't reach, right?
So it's
like this would be my head. Here's my arm. Here's my other arm, and I'd be like, whoop, 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 whoop. You know what I'm saying?
Nothing.
And I'd just be all like, I'm cool. Like, I'd keep like the straightest face. Like, it would be so cool. It'd be awesome. Look at that. Man, that's an amazing drawing right
Pretty
there.
good face.
Yeah.
Why would you get rid of it?
The 10 looks like his ear.
Did it? I'll have to look back at the video.
Or you can just do
but anyways.
redo.
So how many triangles are formed by this?
0.
0 triangles are formed.
And that is the answer to 11 and 13.
Okay? Missed the O there. All right, so 0 triangles are formed. Let's consider one more situation, and then I got to go. What if little b... Actually, I'll label it as a second example. Yeah, you can head out there. Let them know I'll be on my way. Little b is 8. Little c is 10. Capital B is 118. So, for this...
0 triangles.
Which one is the adjacent? Which one's the opposite?
Oh boy.
B is the adjacent.
No?
No, 10 is the adjacent.
How do I know that B is the opposite?
Because it's smaller.
Because little b is always opposite of big B, okay? So then C must be adjacent. So guys, check this out as far as the sketch goes. Angle B is crazy obtuse, right? It's 118 degrees. All right? So check this out.
That's great.
The adjacent is 10, and the opposite is 8. So here's 8. Is 8 going to be far enough to hit?
No.
No.
How do I know?
Because 8 is smaller than 10.
Because 8 is smaller than 10. So now this is like, if I was a swimmer going through the water, that's what it would look like, and I'd have water right here.
Oh, that's pretty good. Oh, wow.
Wow, man,
Look at that.
mind blown.
Look at sad face. Oh no, that's the angle.
That's the angle. Wow, yeah. It was like a sad swimmer.
Sad.
No, it's on the video. You'll have to catch it on YouTube later.
On the YouTube.
So 8 is less than 10, and the angle B was obtuse. So looking at our little sheet, what situation do we have? Even though I know you guys already answered it. We're in an obtuse situation, and let's see, did I say the adjacent is larger than the opposite?
Yeah.
So no triangle is formed.
Oh, body.
Right, and you can kind of visually see that. All right, so I want you to kind of draw the pictures, just so you can kind of see what's going on there as well.
Visuals will definitely help.
So no triangle
Oh,
formed.
shizzy, man.
All right. So that's all we're going to do today. So you'll be doing those analyses using that little chart. It's all about figuring out, are you in an obtuse situation? If it's acute, you have to find the height. Yeah, he's a cutie. Yep. So anyways, that'll be all, folks.